Okay, let's try to use the guess framework to solve a hang time problem. So, a basketball player jumped straight up to grab a rebound. If she was in the air for 0.27 second, how high did she jump? All right, so when we do this one, let's do our diagram first. What's going on here? She's jumping up into the air, coming back down, and that all takes 0.72 seconds. Okay, so first off, we're going to take this. I'm going to move this over a little bit so I can write my guess over here. So here's my G, my U, my E, my S, my S. Okay, so first we have to identify what we're given. A basketball player jumped straight up. Okay, I'm going to stop there. Jumped. When I see that, I know two things right off. One, that when she jumped, she's in the air, therefore gravity is the only thing acting on her. And so I'm going to say G equals 10. I also know that when she's jumped and she goes up and comes back down, at this point right here, I know that her velocity is equal to 0. And then I also know she was in the air for 0.72. So T equals 0.72. So I've got to figure out I'm going to work this right here, this V equals 0. Because when I look at this problem, I want to know how high she jumped. And that's this distance here. So I'm going to go ahead and identify that right now, that the D, the unknown, is our distance in the vertical direction. So then our V here, that 0, I can look at it in a couple of ways. That's her final velocity from jumping this part here, or I can look at it as her initial velocity as she falls back down. And that's the way I want to look at it, because I want to look at the second half of the problem right here so that I can make this VI and say that the initial velocity was 0 as she fell from her height there. So I'm going to go ahead and fill in right here that VI equals 0. So now I've got three givens and I have my unknown. And so I'm going to go ahead and identify the formula that I'm going to use. My equation is going to be D equals, and it's going to be VIT plus 1/2 GT squared. And so that's the full formula written out. And then I'm going to have to go ahead and substitute in. And actually, before I do that, I'm sorry, I'm going to get ahead of myself here. Notice that that over here, that this half of the problem right here, she fell from that height. And in the first half of the problem, this over here, she jumped to that height. So the entire time that she was in the air is 0.72, but she jumped to that height and then fell from that height. And so the 0.72 is the entire time. I only care about half of that. So the T over here is going to be half of that, which is 0.36, because it took 0.3 seconds for her to jump up to this level and then 0.3 seconds for her to fall from that level. And so when I plug in, I'm going to plug in not 0.72, but 0.36. Okay, so my VI over here, the VI is 0. So my VIT, this is all going to go to 0. So I don't even need that part. So when I substitute in, I'm only going to substitute into the 1/2 GT squared. So I'm going to say D equals 1/2 times 10 times my time. And again, I'm going to use 0.36 and I have to square that. Okay, so then as I continue with that, I'm going to get D equals 1/2 of 0.36 squared is 0.13, and 0.13 times 10 is going to be 1.3. And then if I take half of that, I'm going to see that my distance equals 0.65 meters, and that is my final answer. Okay, and again, the difficult part of this was identifying that it took 0.3 seconds to jump up and then 0.3 seconds to fall down. But either way, the distance covered was only 0.65 meters on the way up and then 0.65 meters on the way down.